Financial Modeling, Topic 2, Section 2. Computing asset return variance and standard deviation using formulas and functions. So we'll start with our Start Excel file. And you'll notice in our Start file, we have the returns of COF, Capital One, Walmart, and Brew, SPY, IOO, EMA and EFA indexes, or our ETFs. And at this point, these are just returns that we actually calculated in the first topic from 2019 February down to 2014 in April. So these are monthly returns for these assets. We'll calculate the average monthly return by just taking the average. I'll open that, Control Shift down. So there's my monthly average return for Capital One. I'll then take that number and multiply times 12, and I get an annualized average return based on monthly data, and I'll copy that across. So these are the average annualized returns for these particular assets. Capital One 6.03, and you can see the lowest over here is the emerging market, or the EFA fund, 2.88%. Now what I want to do is I would then calculate the standard deviations and variances of these asset returns. In other words, I want to measure of the distribution, the fatness of the distribution of the returns around this, say, monthly return of 0.5 for Capital One. So what I'm going to do is I'm going to come over here, and a measure of my distribution is going to be standard deviation. But to get standard deviation, I first need to calculate variance. So what I'm going to do is I'm going to calculate variance, remember our formula, it's going to be the average square deviation from the mean. So I'm going to carry in this part of the spreadsheet for Capital One in February of 2019. I want to get the return in that month, 3.71%, minus the return, or the average monthly return of 0.5. I'm then going to put a dollar sign in front of the 2. So what that means, well, first of all, let's see what the calculation is. I'm going to take 3.71% minus 0.5. In other words, in this month, it was about 3.21% above its mean. I'm then going to square that. Now, putting a dollar sign in front of the 2, when I copy this formula down and over, it's going to make sure it always stays in 2. However, when I copy it down, it's going to stay in 2. However, when I copy it over, it's going to go to C, D, because I didn't put a dollar sign around the B, in front of the B. So that right there is the square deviation from the mean in the first month for Capital One. I'll copy that over. I'll copy that down. I'm going to hit my N button, go down to the bottom, make sure the bottom looks good. Come back up. So for Capital One, I have my standard deviations from the mean. I'm sorry, my square deviations from the mean. Now if I simply take the average of the square deviations from the mean equals average, and then put in these numbers, you can see that formula right there. The average square deviation from the mean, that is my number, or my statistic called variance. If I copy that across, let's see what the riskiest asset was. The riskiest asset is Brew. It had the largest square deviation from the mean. Now, squaring it is simply a trick to make sure the pluses and minuses of above and below the mean don't cancel out. However, then that modifies my data. It makes it squared returns. So what I'm going to do is I'm going to take the square root of that number. So take that to the 1/2 power. Now this number here, it returns to the original units of returns. I'll copy that across. And what you see is Brew still has the highest dispersion around the mean of 13.44%, which means we can use that standard deviation to start making inferences about the probability of low or high returns for Brew. Now, I don't need to actually do this math to calculate square deviations. Excel has a nice little tool. If I just use equals var p, and I go to the original returns. Control Shift down and just take the variance of Capital One's returns. I get 0.37. I can copy that across, so I could have done a shortcut. I didn't actually need to do all this area right here. And I can use equals STD EVP, that's the population standard deviation of the Capital One original returns. Control Shift down. And I get the same value as before, the 6.09%. I can copy that across. I also want to show you that these are called population statistics. So if we go back to the PowerPoint, I want to make a point here. By the way, here are our returns. Here's our data we've done so far. And what I want to show you is that you can also calculate sample statistics. Now this course will generally use population variance and population standard deviation. In other words, use VARP and STD EVP unless I tell you otherwise. And I'm going to be using that for most examples. Now, sample statistics should be used when dealing with small samples in the real world. Now, the only difference is, think about when we calculated variance for the Capital One. I took the average squared deviations from the mean. In other words, if there are 70 observations, I would add up the 70 squared deviations from the mean and divide by 70. That is the population statistic. Now the sample statistic, I would simply divide by n-1 observations. In other words, I divide by 69 and I would get a little bit higher number. So now in practice, we usually have lots and lots of data in finance. Therefore, the difference between dividing, say I had 1,000 observations, dividing by 1,000 and 999 is very small. So in general, it's not a big deal, but in practice, we should be using sample. But for this course, for demonstrative purposes, I'm going to be using population statistics. So I'll go back here and I'm going to just calculate the sample statistics. And all I do is do var instead of varp. So I just drop off the P for population, grab my Capital One returns, and notice it's 0.38 and not 0.39. because it's dividing by n-1, and I can do equals STDEV, no P. Put in my Capital One returns. All right, notice I just have var and STDEV, no P, and you get slightly higher numbers for the sample statistic. So in this topic, we calculated the asset returns using both formulas in Excel and the functions. Now, anywhere in my assignments I ask you to calculate standard deviation or variance, you don't need to create that extra spreadsheet space where I calculated the deviations. You can just simply use those functions of STD, EVP, and VARP. In the next topic, we'll talk about scaling standard deviations across time.